Hello everyone! In these next example problems, we're going to be talking about key features of square root graphs. So it's going to be pretty cool. You guys will be able to graph these on a graphing device. Okay, on a lot of these problems, you guys, using your graphing calculator, unfortunately, will not be able to help you find a lot of these key features. Unfortunately, your graphing calculator is limited and certain features are impossible to find on your graphing calculator. But Desmos.com, you can find all of these key features, which I'll kind of explain why you can't use your calculator on a lot of these, but again, you can use Desmos.com to find all of these nifty key features. Now, on one of the problems, you can use your graphing calculator to help you solve, so I will show you how to do it. But on the rest of these, I will be showing you how to find all of these lovely key features which we found using a quadratic graph. So hopefully some of this will be kind of a review. Anyways, I'll be showing you how to find these on Desmos. And again, you should have a worksheet that has a printout of all the graphs. Now, I do want you to practice graphing these because you won't always be given a graph. So you need to know how to graph these functions yourself. The reason why I gave you a printout of the graphs was so when you're looking back over your example problems, because I know you guys are super studious and you look back over the work you did in class. So when you look back over the work, your work will make sense. If you don't have the graph, what you're writing down for examples 5 through 8 will really not make any sense. Okay, so make sure when you guys are doing these problems that you probably should minimize your screen, your video screen, so it's only taking up half of your computer screen, and then on the other half, you can pull up Desmos.com and practice graphing along with me. Okay, well, let's get started on example 5. We're going to start by graphing this on Desmos.com. So I'm going to show you how to do that first. Example 5, unfortunately, graphing it on a calculator is not going to help you, and I'll explain why in a little bit. But for now, let's start graphing on Desmos.com. So we have y equals, if we're looking at example 5, it's y equals the square root of x minus 2. Okay, so there's two ways you can pull up the square root button. Okay, you can either click this keyboard button and hit the square root button, like that. Okay, or another thing you can do, which actually using this shortcut works on a lot of different graphing websites, or if you have to type in any kind of math notation onto a website, usually this shortcut will work. You can also type SQRT. So SQRT, and whoa, do you guys see that? A cool square root pops up. So either way, you can type SQRT, or you can just hit the keyboard button and click the square root button. Whatever makes you feel more comfortable. Okay, so I'm going to type x minus 2. Now, how you get out from underneath the square root, I'm going to hit my right arrow key, and if you see, now I'm not under the square root anymore, and then I'm going to click plus 3. Okay, so this is your first function. Again, these are the equations we'll be graphing for 5, 6, 7, and 8, so just keep that in mind. Okay, so first of all, when we're looking on here, okay, so let's see. All right, the first thing we want to find are the x and y intercepts. So where the graph smacks the x and y axis. So again, I know you technically have the graph on your paper, okay, but again, technically you weren't supposed to be given the graph. I want you to actually practice doing this on Desmos. Okay, so looking at the graph on Desmos.com, if you see, holy hot dog, you guys, the graph never crosses the x or y axis. Okay, so this graph doesn't have any x or y intercepts. Okay, so on my paper, I'm going to write none for those two categories. So if you guys see here, I wrote the equation at the top, just so you know which equation we're talking about. So our x-intercepts, we unfortunately have none, which is sad. So I'm going to put a sad face. It's always sad when we don't have a key feature on our graph, right? All right, and also the y-intercepts, we don't have any as well, so none. Sad face. Okay, now the minimum and maximum, this always occurs around your start point of your square root function. So wherever the graph starts, before it either continuously increases or if it's facing downward, continuously decreases, this point right here, you guys, will always be either a maximum or minimum point. And if you look here, since the graph always is either continuously increasing or if it's facing down, it will continuously decrease. Okay, that means your graph either has a maximum or a minimum point. You can't have both because the graph is either going to keep going up for forever or it's going to keep going down for forever. So looking here, if I look at the start point on this graph, which is the point 2, 3, okay, this will tell me if this is the max or minimum. So is this the absolute highest or absolute lowest point on this lovely square root function? Holy hot dog, you guys. You guys are insanely smart. Like, I don't know why I teach you guys. But anyways, this is the absolute lowest point on the graph, like you just told me. So, this graph has only a minimum. It doesn't have a maximum because the graph is going to keep increasing for forever. So, to infinity and beyond with Buzz Lightyear. Okay, so on my paper, for the minimum, so again, this point right here is going to be a key point. Okay, which I'm going to highlight it because it's very important. Okay, this point will tell you if it's a minimum or maximum, which in this case we know it's a minimum. Alright, so that start point is actually going to help us find a lot of things on our graph, okay? So, or that point is going to help us find a lot of our key features from our graph. Sorry. Okay, so this problem only has a minimum, and that minimum point is at the point 2, 3. So unfortunately, this doesn't have a maximum. So again, it's a none, and we're sad again. It stinks when we don't have key features, you guys. Which unfortunately, one of these two will always be none because you can only have a maximum or a minimum. So unfortunately, we will have a sad face on each problem, but it'll be okay, you guys. If we just have one sad face, I can handle that. Right now we have 3 sad faces, which this is really depressing. But anyway, so the end behavior. So this will be done the same way as when we had a quadratic graph. So end behavior, remember, we want to know what's happening at the ends of the graph. Okay? So basically, we want to know where the graph is approaching as x heads to negative infinity, which is the left side of the graph, and where y, or the graph, is approaching as x approaches positive infinity, or on the right side of the graph. Okay, so we're going to take a look at the left side and the right side of the graph, and what you fill in right here is what y is approaching, which is what your graph is headed toward. Okay, so your end behavior will always look at this. We're always curious to know what's happening on the left and right side of the graph. Okay, the part that you fill in is what f of x, or the y, that is being approached, or where the graph is headed as we're headed in the correct direction. Okay, so first of all, okay, we want to know what's happening as x approaches negative infinity, or is heading to the left. So I want to know what y value is the graph approaching as we head toward the left, which on these graphs, you guys, you're actually going to approach a value. Okay, the reason why when we had quadratic graphs it was positive or negative infinity is because the graph kept going for forever. Okay, so if you guys see, as we head to the left, so this is the left side, as we head to the left, what y value is our graph headed to? Okay, our graph is headed toward the y value of 3. Okay, so this is what our graph is approaching on the left. Okay, so in all these problems, as you head to the left, it will actually approach a value. Okay, so as we head to the left, the y value, or f of x and y mean the same thing, the y value that we're approaching is 3. Okay, so I'm going to put 3 right here. Now, as we head to the right, so this is the right, okay, which these graphs have an arrow, which means it's going to keep heading in one direction to infinity and beyond with Buzz Lightyear. So as we head to the right, where are your y values headed? Are they headed upward or downward? Okay, well, this graph is steadily increasing. Okay, again, it increases really slowly, but it's going to gradually head upward. So we're heading up, or in a positive y direction, for forever. Okay, so if you remember from when we did quadratics, when we head up for forever, that is a positive direction, and we're going to head up for forever, which means we're headed to infinity and beyond with Buzz Lightyear. Okay, so again, this means if the graph is heading up, we're going to put a positive infinity. All right, so the graph is heading up on the right. Okay, so basically, when we head to the left on these graphs, it will approach a value for the y because this graph has a stop point. It has a start point, which means it's not going to keep going. So on the left side, we'll approach a number. On the right side, the graph will continue on. So we are either headed up or down for forever. So that will tell you if you're going to use a positive or negative infinity. So just keep that in mind as we're solving. All right, now the next thing, we will have either an interval of increase or decrease. The graph, if you guys see, is either always increasing or always decreasing. Okay, which the way that you know if it's increasing or decreasing, if you trace your graph from left to right, like when you read a book, if you head upward, you're increasing. If you head downward, you're decreasing. So this graph is headed upward for forever, so we will be increasing for forever. Now, don't forget, you guys, when you do intervals of increase, okay, we want to know the x values that cause the graph to increase. So this will always occur at this point, and it'll be whatever the x value is, because I want to know which x values cause the graph to increase. Okay, so we're going to start at 2 on the x, because that's our start point. Okay, and we're going to be increasing for forever, so unfortunately we're going to have another sad face. The decrease will be none on this one. Man, so many sad faces. Okay, so your intervals of increase, we know we're going to have a 2 involved because that's where we start from. We're going to have an x. Okay, and then we are increasing. Let's see here. Are these x values on this side larger or smaller than the 2? Well, there are things like 5, 10, 15, etc. Okay, so the graph is increasing to the right of the 2, and these values are larger than the 2. So we're going to say where x is greater than the 2. Okay, now we're not going to say equal to 2 because at the 2, it's not really increasing or decreasing. That is our start point. Okay, so we're not going to say it's equal to 2 because we haven't started increasing at the 2. That is just our start point. Okay, so our interval of increase is where x is greater than 2. And don't forget, you can still use that shortcut I taught you before. Okay, if you type x is greater than 2, if you guys see, it's shading over the whole graph. So these are the x values where the y's are increasing. Okay, so if you do this and your graph is not shaded, or if the inequality is not shaded over the entire graph, that means you didn't do it right. Like if you thought it was x is less than 2, okay? If you see, it's not shading over the graph at all, so that wouldn't be right. We want to know the x values that make the graph increase, which since the graph is always increasing, it should be all of the values. So the only one in this case that makes sense is greater than. Now, in all of these problems, you guys, our square root function will be headed to the right. Okay, so if we're headed to the right, x values that are to the right are always larger. Okay, so actually, you guys, whether the graph is increasing or decreasing, this is the direction your graph will be heading. Okay, so no matter if it's an increase or decrease, when you write down your interval of increase or decrease, it should always be x is x is greater than whatever your x value is at the start point. So even if it's a decrease, okay, if this was heading downward from right here, okay, these values would still be shading over the graph. So no matter what, whether it's an interval of increase or decrease, it should always be x is greater than whatever that value is right here at the start point. So that's a little shortcut if you like shortcuts. So intervals of increase, if it's heading up, it's x is greater than that point at the start point, which is 2. And regardless, even if it was heading downward, your interval of decrease would still be the same. Okay, so no matter what, it'll be x is greater than the start point. You just have to figure out, well, is the graph increasing or decreasing? Okay, and then the last step, you guys, so let's go back to our nifty paper. Okay, so this graph is increasing, if you want to label that. Increasing. All right, making sure I can spell. I'm a horrible speller. Okay, but anyway, so our domain. All right, remember I taught you several ways to find the domain. You can ask yourself how far left and how far right the graph goes. which the furthest left it goes is to this point right here. So the furthest left is the 2. So if you guys see, this point is actually very helpful in a lot of cases. So really your domain is going to be whatever this point is on the x. Okay, so how far left it goes? Well, it goes to the 2. How far right it goes for forever because of this arrow. So it heads to infinity and beyond with Buzz Lightyear. And these values are larger than 2. We have things like 5, 10, 15. Okay, so the domain, you could say x is greater than or equal to 2. Okay, don't forget the other way you can do this if you don't like looking at the graph. You can set everything underneath the square root. So I'm going to solve over here because I don't have a lot of space down there. You can set everything underneath the square root to be greater than or equal to 0 and solve that way. So when we add the 2 on both sides, holy hot dog, we get x is greater than or equal to 2. Okay, so if you prefer solving, that's how you get the domain. Okay? Alright, and then lastly, the range. This is when you ask yourself on the graph, how low does the graph go and how high does it go? Well, the lowest value on the graph on the y is this 3. So again, if you guys know the start point, you kind of know the domain and range. The domain is the x in the start point, the range is the y. And then these values up here are higher than 3. They're things like 5, 10, etc. So the range would be where y is greater than or equal to 3. Okay, so if your graph is increasing, your range will be y is greater than or equal to whatever the start y is. If it's decreasing, then the range would be y is less than or equal to your start point. Alright, so those are some shortcuts to keep in mind. Your domain should always be x is greater than or equal to the start point, because again, your graph is always going to be headed to the right. So kind of like with your intervals of increase and decrease, okay, your x should always be a x is greater than. When we're increasing, it's not equal to, because at that point we're not increasing. But the domain, we can equal that value, so that is a x value that is allowed in the problem. So we'll say x is greater than or equal to 2. Alright, and then something else to keep in mind, you guys. So sometimes on Desmos, the start point is kind of hard to find, which you'll see in one of the problems later on. Okay, so if you cannot find that start point, a way that you can find your minimum or maximum point is by finding the domain and range. Okay, so like if you can't identify that point on Desmos, you can find the domain algebraically. Okay, that will be the x in your minimum or maximum. Okay, and then the range is going to be the k value on the end, which is the 3. Okay, so don't forget the range. You could always say that y is greater than or equal to k if it's increasing, or if it's decreasing, it'd be y is less than or equal to the k. So if you're thinking about transformations, remember the range you can also find by identifying the k value. So if your minimum or maximum point, if that start point is really hard to find, you can solve for the domain by setting the value underneath the square root to be greater than or equal to 0. And then the range, you can simply, if it's increasing, you'd say y is greater than or equal to k. If it's decreasing, you'd say y is less than or equal to k. So that's how you find the x and the y value in your maximum or minimum point. So just keep that in mind. If we can't identify that point on the graph, you can start by finding your domain and range, and that will give you the x and y in your maximum and minimum. Alright, you guys, well, that was lovely. I'm going to name my graph because all graphs deserve a name, right? So my graph's name is going to be Sandra. It's a fancy graph, so it deserves a fancy name. Well, there you go, you guys. That's example 5. Let's get started on example 6.